So guys, in the last section we have done with the how many states we have in the OSPF and how many like packets we have in those. So basically we have a types of packet. We have a hello packet, we have a DVD packet, then we have a LSR packet, link state request, then have a LSU packet, and then we have a LS acknowledge packet, right? All these packets, someone mic is on. All these
Okay,
packets,
man. Mine.
all this packet has encapsulate with the IP header. Is it? All this packet will be encapsulated with the IP header. That will be your protocol number will be 89. All this packet, and so whatever the checksum of the IP and whatever the checksum of this protocol, this packet is totally different, right? And we are going to use the OSPF version 2 for the IP people. Clear? Now in the OSPF, what happened? If you remember that in the EIGRP, if I'm going to enable the EIGRP protocol on this link, how EIGRP is working, I'm going to say the router EIGRP number 1, and I put the network 0.0.0.0.0, and I put the router EIGRP number 1, and I'm going to put the network 0.0.0.0. In this case, what happened? Try to understand. Both the router is going to form the neighborship, right? Both the router is going to form the neighborship. Once the neighborship has completed, then what happened? That R1, the 1.0.0/8 LAN network is shared by the R2. At the same time, whatever the information of the R2, now R2 will share this information to the R1. This is how the process is happening between the R1 and R2. So all this route will be exchanged, right? Try to understand. All this route will be exchanged. Is it? So now R2 have a 1.0.0 information/8 information, and in the R2 R1 routing table we have a 2.0.0/8 information, and this is how I'm going to say the ping 2.2.2. This is how the EHRP is working, man, and this is how the RIP is also working. But how the OSPF? If you remember the first class, right? If you remember the first class, what happened once I'm going to put the command router OSPF on a single router? What is the use of this command? The use of this command is going to enable the OSPF process on the router. It's enable OSPF process, right? And second thing, it is going to find the router ID, find the unique router ID, and third thing, it has a separate LSDB table. And fifth thing, it runs SPF algorithm separately on LSDB. Is it? That is the use of OSPF. Guys, 1 minute. Now in the OSPF, what happened? Try to understand this thing. In the OSPF, we are not exchanging the route actually. In the OSPF, I'll show you the LSU packet. In the update packet, we are putting the routes, right? In the update packet, we are putting the route, right? But in the OSPF, do you know what happened? OSPF is not going to exchange the route. OSPF is going to exchange the OSPF exchange the information about link. OSPF exchange the information about link. What is the information about link? What is first of all link? Guys, try to understand. This is actually an interface, right? This is actually an interface. But once I'm seeing that this on our interface, if I'm going to say that IP OSPF 1 area 0, what happened? Now this interface has converted into the link. Which interface? This interface. And what is the information of this interface? The information about this interface, right? The information of this interface, or we can say the information about this link. What is the information of this link? The IP address, right? The IP address, or we can say what is the network ID of this interface, right? The OSPF exchange the information about link. That information is known as LSA, link state advertisement, right? L for route, L for link. That's my interface. State means router, advertisement means sharing. Sorry. So what happened? Once I'm going to configure the OSPF on this interface, by default, what happened? It will send the first hello packet trying to form the neighborship, and he's going to say the only information is R2, right? Same thing, R2 will also done. So from this interface, right, what happened? Now R1 is going to send the own information, own LSA information of this interface, and R2 is going to send the own LSA information of this interface. And this LSA, right? This LSA is generated by every router. Once I'm going to enable the OSPF on this interface, and once I'm going to enable the OSPF of this interface, the information about this link, right? The information of this link is known as a LSA. And every router is going to generate this information. Every router in your network, whatever the router, if you have 20 routers, 20 LSA, 30 router, 30 LSA, 40 router, 40 LSA. And this LSA is known as a Ganpati Bappa Moria. So this LSA is known as a router LSA. Is it? So the first LSA of the OSPF, right? The first LSA of the OSPF, LSA1, is known as a type 1. It also known as a router LSA. The first LSA, right? The router LSA, it is generated by every router that contains the information. The information about link. So simply, this router LSA contains the information how many links are connected to me. What's the meaning of that? First of all, try to understand if you have a 40 routers, 40 router LSA, 20 router, 20 router LSA, 30 router, 30 router LSA, 2 routers, 2 router LSA. And what the information they are going to contain? They are just going to contain the information about how many links are connected to me. So right now, try to understand this thing. If R1 has how many links over there? One is a loopback, one is the transit interface, right? So R1 is going to generate the single router LSA. This is a single router LSA, and in this single router LSA, they are just going to put the two information. One information I'm going to put about the 12.1. That's my transit interface. and another I'm going to put the 101. Same thing, R2 is going to do that. R2 is going to put the 2.2 and 2.2.2.2. So basically, both this router is going to exchange the own LSA information. This router is going to exchange the own LSA information, and they are just going to contain the information about link, information about link, and that information of the link is known as LSA. And this LSA, once R2 will receive this information, it will store in the LSDB table, and it's going to store in the LSDB table. Clear? This is my first LSA, that's known as the router LSA, generated by every router. If you have a 20 router, 20 router LSA, 50 router, 50 router LSA, 2 router, 2 router LSA, 5 router, 5 router LSA. And what information they're going to, they are just going to contain the link information. How many interface we have, how many link we have connected. So right now, only 2 links are connected on R1, right? So take an example, what happened? R1 router, and we have can anyone tell me how many router, let's say, router will generate?
A single LSA contains of all connected networks.
Exactly right. They advertise the single LSA, right? But they contain the 5 links they are connected to me, right? Chalo. Now let's come to the practical of this one. So hope so you understand the LSA. What is the meaning of LSA? LSA is nothing but it's just the information about link. So right now, router LSA is just going to contain the information of link. And this is the properties of area. It will never go beyond the area, right? This LSA, it will never go beyond the area. This LSA is only travel within the area. It will never go beyond the area. Right? Now, area 0 is known as a backbone area also, right? So in this case, can anyone tell me how many data LSA will be there till this point? बताओ, तुम जो बोलो वही मानेंगे, सुनते बस बता दो.
Each router there is a 5 LSA, right?
You are asking me or confirming? First of all, tell me.
Confirming each router 5 LSA.
6 LSA.
Ramesh, this is the same thing that you have told me when you came to the class right today. You said key law. We have 5 people, including you, 3 people, 4 people. So there is a 5 LSA will be there on this router, but totally is 6 LSA.
Correct. 6.
Right? The question is coming, how many LSA? Yesterday, I'll tell you one. If the question is asked by the interviewer, right, how many LSA is there in this area, in this broadcast domain, right? So you will have to say that 6 LSA there. You cannot say the 5 LSA because they are asking the question, how many LSA? If they are asking the question, how many LSA will be there on the R1 router? How many LSA will be there on an R1 router? Then you have to tell the 5 router LSA will be there on an R1 router. Clear? Sure.
Understood.
R6, R7. So right now I'm not going to include this part, right? I'm just ignoring this one. Just ignore this one. Okay. Not interested. Okay, R2, R5. Okay, R1 is not there. R3 is not there. R4 is not there. R5. DR sorry, DR and BDR is the per area basis, right? Sorry, per broadcast domain basis. DR and BDR is per broadcast domain basis, but master and slave is per neighbor
Neighbor
basis.
basis, right?
Right. What is the flag name of master and slave? MS flag is 1, it means it's a master, and MS 0 is means it's a slave. Now, so this is my R1 order. What I'm going to do right now, let me start my so IP interface brief. Do we have any interface? Perfect. R3, so IP interface brief. Awesome. So IP interface brief. Perfect. So IP interface brief. So we have a R4 is not there, right? R6. So IP interface brief. Let me create a one loop back so that it will become the router ID. Okay. Just show IP interface brief. So done, right? So do so IP protocol something. Perfect. No protocol is there. So let me enable the OSPF on this guy. Okay. So R1, R3, R5, R4, R2, R6. Do show IP OSPF interface 0/0. No DR, no BDR because perfect. So I'm done with the DR and BDR, sorry, neighborship. And of course, R6 will become the DR, right? Do show IP OSPF interface brief because R6 has a high route ID because priority will get tied and they'll become high route ID. And if you see that one thing, if you go to R1 router right now, so I have enabled the OSPF right on this interface. So what happened? This guy is going to generate the own router LSA, 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 and own router LSA. So total we have a 6 router LSA in this network. And what router LSA is going to contain? A router LSA. This is the router LSA, right? This is the router LSA generated by a router. So in this router LSA, what happened? They just have a link information. Link means what? Simply say the interface information. How many interface we have? How many interface we have? Now, so if you see right now on a R1 router, right? On a R1, how many LSA will be there? 6, right? Sorry, 5. So IPOs for database, including the R1 will be in the 6, right? Including the R1, we have a 6 one. Now, if you see one thing, The first thing is the OSPF. So this is the command. So IP OSPF database, right? OSPF router ID is 101. That's my own router ID. Process ID, I'm going to use the one. And I told you that if you have a multiple process on a router, you will have a multiple LSDB table. One process ID, one LSDB table. Router LSA for the area 0, right? It means that what he's saying that this interface has connected with the R8 router, and this interface belong to the area number 2. So you will have a same option router LSA for area number 2. Same thing if you have a router number 9 and that's area number 3. So same information router LSA area number 3. So the mentioning this thing is that representing this router LSA belongs to the area 0, right? This router LSA belongs to the area 0. Next point. The first is in a link ID. Link ID means what? Link ID in the router LSA, the link ID is going to represent that
Now, what is that LSDB per area? Is it one LSDB per area? You were
I'll
saying
coming to
something.
that one as well. Just one minute. I'll just come to the point as well.
Okay.
So what I'm saying that in router, let's say the link ID is represent as router ID of the router. This one information, link ID, router ID of the router, right? It's going to represent the router ID of the router. After that, we have our next one is advertising router. Advertising router means what? Who is advertising this LSA? In the router LSA term, what happened? This will be seen. Advertising router is just going to who is advertising this LSA. So this LSA advertised by the 101, right? This LSA advertised the 101, and I'm learning this information. I'm learning this information from the router number 1, router number 2, router number 3, 4, 5, 6, so on, as a dynamic way, like a DHCP IP addressing, MAC address table. So I'm learning this LSA information in a dynamic way. What happened? For the dynamic, we have a timer, right? And this timer is going to represent the age timer. Age is just going to represent that how old this LSA is. Age is just going to represent the how old what is the age of this person, how the age is including of this person.
So in that case, there is no expiry for that age.
I'll just I'll coming. Expiry is there, right? There's of course DSCP expiry is there 24 hours. MAC address expiry is there 300 seconds. This also expiry is there.
Okay.
So how the age is including of this person? This, for example, this person name is ABC. How the age is including on a per day basis? 1 year, 2, every month. What if the person has born on the 2020 Jan 13, right? So next year, what happened to 121? It will become the 1 year, 2 year, 3 year, 4 year, 5 years, 2 years, 6, 7, 8. Always, right? Same thing. This LSA that I'm learning as a dynamic. In this case, what happened? This age will be incremented at per second. If you see right now, 342, 345, 348, 352, 356 as a per second, right? In a 1 second, one age will be incremented. In a 1 second, one age. Show IP OSPF interface 0/0. Can you see this is one timer? Transmit delay 1 second. That's going to represent your age time. Transmit delay. The transmit delay 1 second is going to represent your age over there. So by default, it's set to be 1. You can manipulate this thing as well as if you want, you can manipulate this thing. But by default, it is set to the 1 over there. Okay, and because of this reason, the 1 second will be change every time. Clear? If you want to change, you can just go on the interface and see that IP OSPF retransmit, not transmit, transmit, and you can manipulate from this range. So this timer is also clear. What is the meaning of this time? This timer is also clear. This timer is also clear, and this timer is also clear, right? All this time. Now, next point. Next point is going to represent a sequence number. Next point is going to represent a sequence number. Guys, the sequence number is just going to keep tracking the events, right? It is going to keep tracking your events. And by default, the size of this guy is a 32-bit number, same like a EIGRP update packet sequence number. By default, the size of the sequence is a 32-bit number. But in the EIGRP case, what happened, if you remember that, they are incrementing in a integer number, right? 1, 2, 3, 4, 5. In OSPF, also they are going to increment in an integer number at every time. At every time, it's incremented by 1. At every time, this incremented at 1, but this representation is the hex format. And this sequence number is just going to represent that how many times your database table has been changed or modified. How many times your database table has been modified. Every time it is incremented by 1, or the range of this guy is starting point here and ending here. But you will never find this one value, never, because this the first value is reserved and last is also reserved, right? So always you will get the here, always. So let me tell you first thing about this guy. Okay, what I'm going to do right now, I'm going to shut down this interface, right? The new issue has break. Is already part of this one. That's why it's not 4. One minute, let me configure over there. Not so. It's already part of the LSTV. That's why it's not clear. I can show you over there. R6 and R7. So was it? Okay. IP host 1, area 1. This guy and R6, R6, R6. Interface 0, IP host 1, area 1. Can you see that this one? Right, so can you see this point, right? Once I'm going to enable those, the interface 0/0 is going up. Is going up in which one? Is going up is not in the protocol, line protocol, is going up with the OSPF protocol. Okay, and then we are going to build the one route LSA. Of course, I'm going to enable the OSPF. I'm going to build the route LSA for the area number 1, for the particular area, the my router ID 7.7, and I'm going to start from where? Same area, right? Same. And this is the for the process one, right? Process ID 1, OSPF 1, right? So this is the first thing that I'll tell you, the meaning of this line. So IP store database, right? This first line. So sequence number is always going to start with the 1. It's not start with the 0. 0 is totally reserved. Okay. Now, second thing, I told you that this sequence number has been modified at every time whenever your database table will be changed, right? So let's do one thing. Interface loopback number 2. Okay. And do so IP host database. Two things you have to remember over there. What is the timer is happening? What is my sequence number? 6, right? The timer has been reset for this LSA and your sequence number has modified, right? The timer has been reset your LSA. This is only for this one because I have generated the one route, another route on another link on this interface, on this route LSA, on this one only. So every time when your interface goes down, up, this guy is going to modify your database table as well as shut down, debug IP host, LSA generation, interface loopback number 2, shut down. क्या डिबग चलाया है LSA regeneration. See, previously what was there? 7, and the age was reset. Now again the age was reset. 8. So whenever something you are going to be added on the particular router, let's say your age and sequence number will be, the sequence number will be incremented by 1 and this age will be reset. At the same time, your checksum of this guy will be modified. So if you please see the previous checksum, it was 3B, just take the last one, right? 3B, and then F8, right? And now FA. So every time this checksum is going to modify it for, because checksum is what I'm just going to look up. Is there any errors or not, right? Is there any error for this LSA or not? So every time the checksum will change, right? And the link count is just going to tell you how many links are connected to me in particular OSPF routing protocol. In particular OSPF routing protocol. If you see that, do so. IP OSPF interface brief. How many links are connected? How many links are connected? 2, right? But why they are showing the information about 1? Can anyone tell me why they are saying that 1, not 2, 2?
So one of the loopback state is down.
Danger.
Hello.
Yeah, it's correct, Ramesh.
Okay.
So if I'm going to up this guy, let's see. 2, right? If I'm going to create another loopback number 3, and that should be 100.100.100.100.100, and subnet mask will be /8, and IP also of 1 area 0. Do so IP also database. Link on will be 3, sequence number has modified, and the age will be modified, checksum will be modified. Now, this age, right? This LSA age will be refreshed at every 30 minutes. We can say that 1800 seconds. Now you can compare this thing with your DHCP renewable time. In the renewable time, what happened? Before releasing the IP address, in the DHCP, what happened? They are just requesting, hey, just renew my IP. Just renew my IP, right? That's the meaning of renewable time. Same thing, what happened in the LSDB, this age, right? This database table for this LSA has been refreshed at every 30 minutes to check the if no update is happening, right? If no update is happening, if no update is happen, then what happened? This SPF algorithm is going to refresh your database table automatically at every 30 minutes, right? To check is there any update is happening or not. Just refreshing, that's it. But what happens if the SPF is not going to refresh within a 30 minutes? Automatically after the 1 hour, right? Automatically what happened after the 1 hour, this LSA will be removed from your database table. That is known as a LSA age out. The timer of LSA age out is 1 hour, and the LSA refresh time is 30 minutes. So if nothing is happening, same like your DSB, right? If the server is not responding, what happened? I need to age out my IP address, right? With the 24 hour, after the 24 hour. But in this case, what happened if the LSA SPF is not able to perform on if the SPF is not able to refresh my database table, I should remove this LSA from the database, because this is because maybe this is the incorrect information, this is the corrupted information, right? So this is the just a summary information about this LSA, summary information. Let me do that. If you see right now on the R3, how many links are connected? 1. Let me go on R1, R3. Interface loopback number 2. So I already have a loopback. Interface loopback number IPS for 180. Come back to the R1. Age has modified. Previously age was right? Now, let me show you the detailed information of this guy. What I'm going to do right now, I'm just going to capture this link, okay, and I'm going to advertise a one look back on R5. Or outer LS, I'm going to do advertising. So till this point, we are already seeing what is the layer 2 multicast source address will be Ethernet R1, sorry, R5 address, and the type is IPv4. I need to forward the packet to the IPv4 version 4. TTL is 1, OSPF protocol 89, multicast.5. It will send to the all because R5 is a VDR, so it's not going to inform to the .6, right? And then we have a OSPF header. So we already discussed about the OSPF header as well as. So this is the update packet, and we have a LSA update packet. And in this LSA update packet, he's going to tell you how many number of LSA, how many number of LSA. Right now we have a single LSA. It means that this guy contains the multiple LSA. This is the update packet, and in this update packet, he's just going to tell you how many LSA is there. One. It means that they can have a two, maybe three, maybe four, maybe five. Next one, LSA type 1. LSA type 1 is known as a route LSA. LSA type 1 is known as a route LSA. What this guy is going to contain, this is just going to contain the information about how many links are connected to me. How many links are connected to me? Have a look. LSA type 1, route LSA, length is 48 bytes. So LSA ace is by default, I told you that this is the 1 second, this timer, right? This timer. Don't ask me the question about what is the meaning of this thing right now. I'll tell you, okay? Now, next point. I'm not going to right now opening the option field. Remove this portion right now. I'm going to remove this portion and this portion. We'll talk about later on, but not now. Okay. Next portion is going to tell you LSA type. LSA type is already I discussed. LSA route LSA. Opcode is 1. Link state ID is 5 because the route ID is 5 to 5. Who is advertising this LSA? R5. And sequence number of this guy is this guy. Checksum length. Flags. This flag is also I'm not going to discuss right now because this flag is going to represent that virtual link, AS boundary router, and ABR router. This is the part of beyond the. This part comes in the LSA3, right? This part is coming in the LSA3. This part is coming in the LSA5, and this part is coming to the virtual link. So once I'm coming to the LSA3, LSA3, 5, and virtual link, then I'll discuss this flag as well as. But right now, no use. Okay, so I'm also going to remove this one. After that, he's going to tell you how many links are connected to me. 2. Which links? One is a stub link, that's a 5.5.5. Another is a transit link, 1.5. Now for the stub, what is the my submit mask is there? /32 data. Try to understand in look back what happened. In look back what happened in EIGRP. If you I'm showing it, I'm going to show you right now. Let me do one thing. Router 1, EIGRP 1 network 50 dot and network and interface look back number. And I'm going to run with R2 EIGRP. Sorry. चलो चलो फॉर्म कर लो membership हैं? So this look back on a created on R1 that was a /8, right? Right, /8 is there, and even if you check for the do so IP root connected we have, so all we have a /8. This is also /8. Let me do one thing. This is the R1 routing table. If you go to R2 and do so IP root EHGRP, do so IP root, sorry, not EHGRP, what happened? If you see one thing, this route /8, right? And even in the R1 route, R2 routing table is coming with the /8. But in OSPF, what happened if I'm going to advertise this link in the OSPF? This guy is coming with the /32 as a host route, or we can say that stub route, a route that is the last stub network. The stub network that is the last that does not have any connectivity with any other person. Look back always straight in the OSPF, right? Look back always straight in a stub network, stub route, because loopback is not going to provide the any connectivity with any person, right? We have a two types of network in the OSPF, right? One is the stub network, one is the transit. Transit means what? R1 is going to provide the connectivity to the R2. This means transit, right? This link is transit, but this link is a stub, right? This link is a stub. They cannot forward the any data plane traffic. They cannot forward the any data plane traffic. They can forward the data plane traffic. And in the OSPF, what happened? Your route will be advertised as a /32. But in the EHRP, what is advanced /8 host route? That is the benefit of the OSPF, having the OSPF, right? OSPF is able to detect, right? OSPF has the ability to detect, okay, this link is a host link or this link is a transit link, but EHRP does not have. OSPF has the ability to detect, okay, is it a stub or is it transit? But EHRP does not. That's why he mentioned that, okay, this is a look back, let me advertise in the /32. So I'm not going to take a higher CPU lesson as compared to this one. In this case, what happened? /24 host bit, right? In this case, what happened? Single host.
Now, what about apart from loopback interface, we have some other LAN segment behind the router one.
That is also considered transit.
Okay.
Except the loopback.
So it will consider only the loopback, right?
Yeah, stub network.
Okay.
Now, this is the information of your router LSN. Number of matrix is 0. I'll tell you this thing later or not now, this portion. Okay, let me tell you. OSPF does not going to use the toss value. That's why it's putting the 0. OSPF is going to use the DSP value. No, don't ask me question right now. If you don't know what is DSP, I'll tell you in the quality of service. Toss is totally obsolete nowadays. We are using the DSP C6. Clear? Now, let's come to the point of this guy. Let's go to any router. You tell me. I'll just go to R6 router. Okay, what's happening? Now, if you go to R6, do so IP OSPF database. What happened? Okay, do show IP OSPF database router listen. I'm present on R6 router right now. Okay, the network engineer is sitting on a R6 order. And so what happened? The same information that we are it, error order is not reachable. This point I never seen that. Even I don't know what's I mean. Never seen. First time I'm seeing this now. Okay, so LSA is this kind option field LSA type already discussed link state ID or already discussed erroring order already discussed LSA sequence number already discussed checksum already discussed length is already discussed and number of links 1. So R6 is saying that number of links is 1. So let me draw the R6 and the number of links is that is a transit, right? Transit. What is the IP address of this guy? 106. Perfect. And who is this guy? DR, right? एक one. Okay, that's why this influence is coming, right? Advertising order is not achievable. Okay, because OSPF is not anymore. I mistakenly I have removed the OSPF on this interface. I have to remove from this area, right? Interface 0/0 IPS of communication. Let's come back to the R3 order. Forget the R6 right now. That's why that message is coming. Advertising router is not reachable. Do so IPS of database router now. So here no influence there, right? Perfect. So right now the user is sitting on a R3. Let's check how the map is working. The topology of map. So this information already discussed. No need to discuss this, guy. What is saying that number of links is 3, right? So R3, the network engine is this view is done by the network engine right now, and our network engine present on R3 order. He's saying that number of links is 3. By putting a detailed information router, let's say, right? I'm checking how whatever the map of this topology. No, number of links is 3, right? One is stub. 3 links are there, right? One is stub, so that is a 100 or 100 or 100. Right, another is stub, that's a 10 or 10 or 10. And that's a another is a transit, that's a how this guy is giving the info. The router interface address 101. It should be 103. 1 minute.
So router interface address means where it is connected, right?
No, it's not. 1 minute. What's my IP address? It's not giving proper output. 1 minute. R1 is giving the proper output. Okay. R1 is giving the proper output. Why R2? Let's see on R2. एक minute. This should be not there. It should be 1.2 for my case. In my case, because this information of which guy. Shit, man. Sit. It was correct, right? It was correct. Sorry. I misguided from myself. 1 minute. It was correct. He's saying the information about right. He's saying the information about R1, right? Not the R3. So the network is sitting on R3, right? And what is saying that we have a one loop. Sorry, we have router ID. Advertising or link ID is 101. That's my router number one, and advertising router is router number one. On the router number one, we have three links. One link is connected to the stub, another is also connected to the stub, and another link is connected to the transit. Right, this one. So my in loopback is 10.10.10. That's my another stub. Another stub is 100.100.100.100, and another stub is this guy. Router interface address is 101. This interface, and this interface is the transit. That's why I'm putting the transit link over there, right? Now, next information. This is the R1 information, and still network engine is sitting on R3, right? Network engine is sitting on R3, and let's see how they are creating the map. R1 has done. Let's come back to the R2. Now he's seeing that R2 is also there. So R2 will have a R2. Okay. R2 has a number of links is 1, and that is transit network. And what is the IP address of this guy? 1.2. So that is transit 1.2. And who is the DR? Same 105. Same like the R1 is also saying that who is the DR? 105. And R2 is also saying that who is the DR? 105. And my router interface is 1.2. That's my transit interface. I don't have any loopback or a stub over there.
No, it will not show who is BDR.
BDR will not show in the database information. BDR will not show.
Okay.
Now next point is going to show the information 3, right? R3 link connected to the stub network. That's a 3.3.3. If the DR fails, then it will come to the BDR option over there. 3.3.3, and the transit network is 105, right? Sorry, 103. And he's also going to say the same information. Who is the DR? 105. One is stub network, that's a 3.3.3, and another is a 105. Now next is a 404 R4, and R4 is saying that I have a 1 links, and that is my transit, right? That's a 104. R5 is saying that I have a 2 links. One is a stub network, okay, right? And another is my transit interface 105. Perfect. Next is 6.6.6. R6 6.6.6.6, right? And it's my transit network, and I don't have any stub network because number of links is 1. I don't have any stub. We have a router interface is 106. 106. So this guys, so we have done with this LSA, right? Over there. Now LSDB has completed the detailed information. So there's a one switch network behind this guy, and this is how your network is look like this of your router LSA. And still the network engineer was sitting where? The network engineer is sitting on a R3. And based on the R3, they will find the what is the actual topology of this database, of this network. This is the importance of the LSA in your OSPF. And why this is the why we are going to prefer the OSPF in the ISP network. This is the one of the reason. This is one of the reason why we are going to prefer the OSPF in the ISP network, because EIGRP does not contain this kind of information. If you remember that in the EIGRP, what happened? They only have information about your what neighbor, right? Right? Guys, anyone has questions till this point?
Even in DR router also, it didn't show who is BDR.
No, you in the detailed information you can't get. If you put the SOIP OSPF interface brief, then you will get that. Database table you will not. Database table is just going to contain the LSA information. That's it. If you put the SOIP OSPF interface brief, then you will get that.
Okay.
Database is what LSA information. Any questions in LSA 2, LSA 1? No. So next LSA is known as a network LSA. Network LSA means what? As the name says, it's a type 2 LSA. LSA 2. And it is generated by only DR that contains the information how many routers are attached in my network. How many routers are attached? First of all, network is at this point. DR. Only DR. And DR is the properties of broadcast domain. DR is the properties of broadcast domain. It means that it means, is it? We can see that, right? One broadcast domain, one DR, one network LSA, because network LSA is generated by DR only. So in this topology, right, how many network LSA will be there? Use diagram only, this portion.
One.
Of course, one, right? And who is going to generate? Only DR. So if you see, let me find who is my DR right now. So if you see, R5 is my DR, right? Do so IP so database. What is in that? Network LSA. For area 0, who is generating? It means that R5 router, this interface 0/0 is part of the area 0, right? And this interface is a DR. So he's going to generate the network LSA for the area 0, right? 0/1. This is also a DR. For which guy? Area number 1. So he will generate a network LSA for which guy? Area number 1. R6, sorry, another link. 0/3, area number 2, and also a DR. So it will generate network LSA for the different area. So R5 can generate the multiple network LSA. It's not like that, right? It can generate, depend on the DR, because it's generated by DR, and DR is the properties of interface broadcast domain. This is the separate broadcast domain, separate broadcast domain, and separate broadcast domain. right? So what is saying that I'm going to generate the R5 because R5 is my DR. And what information this guy is going to contain? This guy is going to contain the information about how many routers are attached to me.
Except the local router, right?
Local router means local router means where I'm present right now.
Yeah.
There, no?
330. Okay. But compared to LSA1 and LSA2, so LSA1 is total number of links. This is total number of routers, right?
Exactly right. 100%, 100%, 100% right.
Okay. But number of links may vary, but number of routers is a physical routers.
Yeah, it's a physical router.
But links can be vary based on number of links connected on each router.
Exactly. See, can you see that over there? This person, the link 3, link 1, link 2, link 1, link 2, link 1 per router. This is router listen.
Mm.
And it is only generated by the DR, not the backup DR. BDR will not generate, DR only. Clear? Now, so here I'm done with the router number, LSA number 1, LSA number 2. Now you have to do the 3 tasks, not 3, 2 tasks for the LSA 3. Task number 1. Okay, this link, right, is area 0 and area 1. Okay, connect this one. And now you have to analyze the database table, right? Key how many LSA is there? Only router LSA and network LSA. Task number 2. Look back 101. Look back 3.3. You have to provide the communication between this three, this one and this one. And the process ID is going to run on this guy 1. Process ID will be 2. And process ID will be 3. So we have a different process of running all there. Task number 3. R1, R2, R3. Area number 1 and area number 2. You have to analyze what happened. Is it the communication happening between this guy and this guy or not? 3 tasks.
Now on task number 2, what is the area detail? Same area 0 and area
Yeah,
1?
you can put the same area, right? Not same area, different area. Forget the different. Right? Same area.
No, because task 1, there are 2 different areas. What
Yeah,
about
it's
task
a
2?
area 0. Area 0.
Both are area 0. Okay.
Any questions, guys? Anyone has any questions? No. Okay, guys. So see you on the Monday. So no questions. So hope you guys solve this one. First of all, this is the very important for the LSA 3. Okay. Bye bye. Bye bye.
Yeah. Thanks.
Okay. Thank you. Thank you.
What about class tomorrow, La?
Tomorrow, we have the same